Let's finally do a little for the day. It's not like I haven't been doing anything. I've been kind of going over the video and adjusting the audio. Some of the earlier segments had a lot of fanning going on in the background because of this useless AC. A few days ago, my father came into my room and brought me a portable air cooler, and I've been running it for like 2 days, and it's absolute fucking garbage. It was 40 degrees in this room, and it didn't cool at even a single degrees. It was just making a lot of noise and blowing air into my legs. He paid like €100 for it, and he cannot even return it. Idiot. And now I have to find a way to get rid of it. And besides that, I've been thinking what we want to do here. Yesterday we did this. By this I mean, where is the? Okay, here is the game model M, and instead of passing in the output ID into the output function, we instead normalize it. And yesterday I thought that was a good solution, but I realized that it's the wrong solution. And I need to explain why that is. Let's see. Where is... okay, where is the Skelly draw? Here it is. Okay, now let me pause so I can draw things out. And I'm going to explain that right now. First of all, let's do a little chart. On this side, these are going to be bins, and we have one bin for like every thread. Actually, no, we have 128 different bins because that's the minimum size for the matrix multiplication. First of all, let's take a look at this. We have a bunch of bins, and every bin has a probability of some action. So let's say we select this very first bin 0, and it gives us an action call with a 1% probability. So the very first problem that we have is that if we just take the sample probability as this 1%, that's the sample probability of selecting this bin, and not the sample probability of selecting the call action. That's the very first problem. In order to actually get the sample probability, for example, for the call action, we need to group all the actions together and sum up the call probabilities. So here we have 1%, here we have another 1%, 1%, 1%. So something like just based on what we see on the screen, the probability of the call action should be at least 4%. And there are a bunch of other bins as well, which we need to sum up. The same goes for the arrays and the call actions. They'll have other bins which will have their own probability, and we need to sum them up. Another issue is that the sampling probabilities for the ensemble won't be correct. For example, ensemble number 1, it might have the call probability here of 0, but over here it might have something like 5%. So based on this, we'd assume that with a current approach, we'd assume that the first entry in the ensemble would have a call probability of 1, and this one would have a call probability of 0, while in actuality it's at least 5%. And that's a problem. I get the sense that this isn't really the behavior that we want. We really want to integrate the sum over all the actions. And we cannot do that like this. You know, when we're taking this approach. In fact, this is the exactly wrong direction to go in. I have no idea why I did this yesterday. Well, I know exactly why I did this yesterday, but it was the wrong reason. Instead, what we need to do, I meant to go to the browser. Instead of having all these fucking bins, what we need to do somehow is get rid of all the other bins. 0, 1, that will leave 0, 1, 2. And get rid of this. And let's say this would be something like 50%, 30. In other words, we want to make sure that the probabilities of the three bins sum up to 100, and that each bin is responsible for one action. In other words, it should be like a one-to-one mapping. And if we did that, it would be a lot easier to deal with than having 128 bins. So I spent a bunch of times. I spent a lot of time today thinking about this. And the main issue that we have is that a lot of the kernels that we have created, they need to have sizes that are powers of 2. But over here we have 3 actions. So I've been thinking maybe, maybe we could convert the matrix multiply so it uses the one from Catalyst, but that would be a cool video on its own, even though I'm prepared to do it. Another issue is that RowMap and RowReduce also need powers of 2, so what exactly am I going to do there? Like, they also do the factorization, so the loads are efficient, but after that, if you put in 3, it won't be able to distribute all the threads in the block evenly, and that would give us an error. And if we tried making a kernel, that's flexible enough to handle any size, that would make it a lot more complex and complicated to deal with. So I was really busting my head for a while there, and I do have a solution, and that's to just, do filtering. Instead of literally, eliminating, not doing the work for any of the other bins but 0, 1, and 2, we should in fact take the softmax over all 128 of them, but also do masking so that the probabilities of all those other bins being selected is 0. So what we should do is simply implement a masked softmax function. That's what we're going to do. And there's more that I want to take this. There are more directions that I want to take this in. Right now, it would be possible to actually do, to raise, fold, and call always, but in some cases, for example, in the very first turn of the hand, you don't want to fold right away. You at least want to call and raise. And there are some places where you cannot even raise. So selecting that kind of action, won't need to be automatically converted to a call. In fact, come to think of it, on the very first turn, we could in fact just convert it to a call as well. If the agent says on the very first action to fold, to throw away the hand, if that is a purely negative EV action, which it is on the very first turn, even if you have the worst hand in the world for any kind of poker game, it costs you absolutely nothing to just call and then fold if the other guy raises. So if the context allows for it, we'll just convert the fold actions to calls, and if raises are not allowed, we're going to convert the raises to calls. And that way we don't need to do any complicated filtering in the graph itself. Okay, I just got this idea right now, so it kind of intrigues me. I had to voice it out loud. Damn it, I didn't go to time. I didn't go to bed early enough today either. Okay, I promise. This time I'm going to set an alarm at 11:30 p.m. and if it starts ringing, I'm going to just fucking stop and go get dinner and then go to bed. Because it's not just that I'm going to bed late, but it's kind of starting to ruin my right hand. So yeah, forget all of this. Did Spiral even update yesterday? Oh yeah, we released v12.6. Is it really v12.6? I thought it should be v12.5. Really? Oh yeah, we added the hash map set operation to the language, and the v2.12.5 is when we fix the bug in the generalize function. Yeah, I've been going through the video, and so it kind of got mixed up in my memory. I had to get in touch with the guy doing this, and ask him what kind of work he was doing. This version has like 50 installs, so I'm curious what's going on his side. But at the very least, we're going to finish this video first. I don't feel like doing anything but programming on Spiral, not doing anything other than working on the machine learning library. I want to at least get the model to work, and this fucking video is 17 hours and 30 minutes long already, and it's going to be even larger. Who knows how long it's going to be by the time it's done. Good thing that I'm not doing this in Camtasia. When I started my YouTubing career, I was using Camtasia, and that program is simply so damn bad, even though it has a great front end. When the video gets greater than 10 minutes, the program basically becomes unusable. It's so useless. The program is all front end and zero back end. I do miss some features from Camtasia in DaVinci Resolve, like the transitions that it has. It has a better front end than DaVinci Resolve, at least for making screencasts. Okay, let me think. What exactly am I supposed to be doing now? Yeah, we need to implement the masking function. And how will we mask things, you might ask? Okay, let's go into the layers. We have this discrete sample, we have this Softmax. And of course, we'd want to maybe we'd want to use that kernel that we're going to do with the Softmax itself. Instead of Softmax, we'll have masked Softmax. But for now, let's just do the masking function, like mask. And this will just be the regular Softmax, and this will be the output probes. Yeah, okay, so it has the output, but maybe we'll want to, you know, also pass it the input. And if we're going to do that, oh yeah, we need instead of mappy, we need okay, we're going to implement first a mask and a reduce. Let's do map e, and let's name this to row map. We don't need the map I. Row reduce. And this ends up eliminating the final function. I mean the final dimension in the tensor. Not bad. Let's also do the. We'll make this a templated function. Out. This will be out. Not bad, and we can. Then what we can do is just row map. Row map, and then f some out. And this will be and you know, this is a library, so it's fine to have some repetition as far as I'm concerned. Reduce. Yeah, this is fine. I'm basically very tired of, you know, having to write out everything like this. Who knows, maybe we'll have to put these at the very top and then, you know, reduce all of these. I mean, redo all of these so they use these row map and row reduce functions. Yeah, it's fine for now, whatever. Let's just put them on the top. Implement the rest. Reimplement the rest of the functions so they use map. And we can also do this here. Get rid of the constraints on the type variables. Not bad. And okay, now that we have the row reduce, I kind of want to do like a mask function. Mask And okay, so it has a f, and it has an out and a what. We have row reduce, and that takes in fun config xi j tensor. Maybe I should also be using x tensor. Let's see. We need to pass it the out. I mean, we don't actually even need to. We can just partially apply it. Okay, so what we need to do, I mean, we need to do a local map. Okay, so let's do a local map. Actually, we need to, let's just for now zip these, zip x and j tensor. And now we have the element and the index. Why is this the? Shouldn't this be like an integer? Yes, yeah, it very much is an integer here. But over here, okay, this one doesn't matter. Okay, what's f here? T dim. Wait, this isn't right. What the hell is this? Reduce f x j tensor. Okay, so it's not supposed to be taking in the config. But I think it, in fact, it should be taking pretty much everything. Okay, so let's do it like this. If it needs to take in the layer state, then let it. Layer state, row config, tensor. Okay, perfect. Oh, wait, what is this? Wait, just a second. Here we have the. Oh crap! We're not supposed to have the same input and the output type. Okay, so let's do AB. In fact, let's go to release. We'll just redo them. Row map. This is A. Sorry, yesterday we had to abort the session right in the middle. And, I was saying that I'm going to go to bed at 11:30, and I lied. I went to bed at 1 AM, and then I couldn't fall asleep. So I'm pretty tired right now. Eventually I'll get tired of, XCOM, and my sleep pattern will get back to normal. Previously, I've been playing Girls Flow. I mean, no, not Girls Frontline, but Vanishing Grey Raven. And I kind of cleared most of the main content, and it's and I completely lost interest. I really regret buying those monthly passes because it's forcing me to keep logging in and do the dailies. Otherwise, I would have dropped the game already. I mean, it was really fun for a good while, and then it got boring pretty fast. And the same thing will happen with this game. And hopefully I'll be able to focus on programming, and let's do that. I'm going to try to do some work right here. Here we have the mask function. I've been also thinking about using this with the Softmax, but we'll do an example, you know, just like this. Okay, so what exactly should we put in? Wait, this is a row reduce, really? I have no idea what I was thinking when I made it like that, but okay, I have to pause and actually think about how I want to do this. Yeah, this is so embarrassing. You know, yesterday I broke this session off so I can go to the beach, get some exercise, which is purely for the sake of my health. And I was really in the zone, and this is one of the times I really regret just stopping right there in the middle. It's unfortunate, but I'm going to have to think about what I want to do here. Just a second. Okay, I had an idea. But you know what, it's kind of... This masking function doesn't really make sense to have it... It doesn't make sense to have it in isolation, so... You know, let's just implement it properly here in primitives. I mean, we don't even need a mask, we're just going to do a masked softmax instead. I don't want to think about this too much. Where is the local softmax? Oh, so it takes the average. Okay, okay, that could be a problem. Let me just pause again. My original plan yesterday was to come in and after the Softmax just set the values that need to be masked out to 0, and then to renormalize it. But now that I'm actually looking at this function, I realize that this averaging that we are doing for numerical stability would get affected in a negative way by that. It would be a lot better to take the average, I mean, to first do the masking and then do all of this. But it's not that simple. In particular, this average. If we set the... Well, we could set the x value here to something like negative infinity. But if we do that, this averaging wouldn't work properly. So that's a problem. So I guess what we could do is implement masked average. Why is it I'm pressing the wrong key? So something like oh no, not like this. Okay, so how about we just do the local map, and here's the x. It needs to be zip x. I mean, I have a bunch of ideas how all this could be done, and I'm not really sure which one is the best. Okay, okay, first of all, whatever, let's just calculate the masked values. And this function will be fun xj why is this wrong? Expected symbol as the tensor key. Wait, what record is it talking about? Oh wait, this doesn't need config. Okay, let's do this config. And we'll have this just returnable for now. So this will have a simple type signature ABCD bool. And okay, what we'll do is compute an average that takes takes the mask into account. Okay, so the best way to do it is let's do mask, then local map fun x. If x then 1 else 0, local reduce config 0. I mean, we can just do a local sum, and yeah, we need to pass in the config. Okay, this isn't bad. Oh yeah, but that's just the sum. We also need to add those values that aren't 0. So okay, here we have the mask. Okay, let's make the mask. I mean, let's leave it like this. X Okay, now we'll do a local map. And in fact, okay, a local map, and we'll zip x mask. Fun. Yeah, so what we want to do, okay, if mask, then x else limit min, and that should be for a float, that should be negative infinity. And now we need to compute the for fuck's sake, this is right. Do we need to do a reduce? I mean, wait, to compute the average, okay, to compute the count. Wait, so actually maybe I need to, okay, we need to the count and the sum, you know. Yeah, I keep using this excuse, but and it's my fault that I'm tired, but I kind of am, so I'm not really thinking properly. In order to actually do a sum, the 0 is the neutral element for that. So okay, we have the local map like this. I can just do this like so, and then yeah, we can just do a local sum config, and then sum divided by count. Now, as for this, let's also do zip mask. If mask, then limit min, and that should set this to the negative infinity. So it's either the regular value or negative infinity. No two ways around that. And great, it's basically not really counting the masked out values. It's not counting the sum that are masked out, and that's pretty good. In fact, let's make this an integer. And we'll put a convert here. Now sum is something and count is always an integer. I don't want to actually, accidentally have numerical stability issues when calculating the count. I mean, okay, so this way of doing it this way of doing it is right, but you know, suppose we do have some numerical stability issues here. It doesn't actually matter as long as the entire softmax is good. Yeah, that's pretty good. Wait, and this actually, no, not the limit mean. We'll just make the softmax here on 0. That's to represent the 0 probability. Okay, let's factor this out. Mass average and that will be x mask I thought of setting it to negative infinity, but that will have to be done before this gets executed. So something like for example, if then x else limit min, you know, x yeah, this is a bit hard to read. Let's just put it on 2 lines like it was before. And yeah, this is pretty good. Now imagine what will happen if x is negative infinity here. X minus average, that's just still negative infinity. And then the exponent of negative infinity is just 0. It's easy to prove that. Okay, let's set the language to F#. Let what is this? Where is it opening this sidebar? exp minus actually system single min value, or actually, oh, that's not a negative infinity. This is negative infinity. And if I press Alt and Enter, what happens? 0f. That's a 0 value. Okay, and now without that, just so you can see that this is negative infinity. Yeah, it's in fact negative infinity. So yeah, the exponential of negative infinity is 0. Okay, now where were we? Wait, where is the X here? So I mean, I think this should also optionally be taking in the layer state as well. Okay, let's do some type annotations. Layer state raw config. Really, you don't have layer state? Maybe I could move layer state into the primitives module. But you aren't opening the primitives here, really? Oh, whatever, it can be partially applied in the mask function, it doesn't matter. So mask, and what are the types of these? I mean, the J here, okay, this should be a boolean. No, this should be an integer. Where is it? Oh wait, this should also be getting an integer. Yes, sorry about that. Oh, okay. Yeah, I forgot the return type. Okay, now this should look a bit better, yeah. I like this. Previously it looked like this. Okay. Yeah, this is fine. We have this masked Softmax. The layer state can be partially applied into the masking function. And now this should do some good stuff. Okay, let's go back into the layers. Softmax. First, okay, let's just paste this. Yes. And we need to pass the masking function into this. So okay, that's the first function in line. Wait, no, not here. And it takes in config xij. What the hell? Config xij. At least that's how it should be. It needs to be this could actually be a theme. Okay, I see. Okay, we finally did this. I don't think we need to put the arguments here explicitly. Yeah, perfect. And what we have here is pretty much the same as the regular Softmax, but we can also make some kind of condition like let's see. Okay, if j less than size, yeah, in fact we can just do that. J less than size. Now if we put in, like, if we have 128 elements and we put in the size as 3, it will just return true for the elements 0, 1, 2 and false for the rest, and they'll get masked out. The only really confusing thing is where are we getting this type error? Oh yeah, we need the size. I guess, yeah, we'll have to pass that in everywhere. Size. 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 Oh yeah, this is the masked Softmax. Let's leave the layers aside for a moment. We also leave this aside. We'll go back to the primitives and we'll actually, test it out. We need to do, some sanity checking. raw map fan config. I mean, let's not do that. Okay, let me think. M and N are 1024 and 4. Now this one is 16 and this one is 256. And just you know, take the first 4 elements and okay, local softmax, I think local mask softmax, and we'll take in a mask and fan config xij, and let's make j less than 4, and then let's do yeah, input output mask softmax mask softmax, and now let's run this. No, wait, I didn't mean to do that. There's no point in running this in PowerShell. Let's okay. Let's close this. We can also close this. Visual Studio Code keeps stale terminals around. Well, let's do spiral build file, and then we just go to the right, go into the primitives, and then Control F5 to run this in the Python interpreter. Oh, we're getting something. Let's see, 0, 0, 7, 9. Yeah, these are the first 4 elements. 7, 9, 13, 28, 15. Yeah, this I think sums up to 1. 33, 36, 16, 14. Yeah, that makes sense. It sums up to 1. 42, 21, 20, 15. Yeah, I'm guessing that also sums up to 1. Of course, I'm not really calculating that exactly. I'm just eyeballing it. Now, yeah, the mask softmax works, and this is how I wanted to do the filtering of unused venues. It's actually a bit more difficult than I anticipated it would be, but this is yeah, tractable nonetheless. You know what would be great to have for performance reasons? Right now we have okay, here we have the discrete sampling, but here we also have the local discrete sampling that takes in the input from a softmax. And the reason why we cannot you know, have this output both values is because okay, I won't go through that idea, but what I wanted to suggest was fusing the raw map and raw reduce into a single operation. It's not really worth doing right now. Let me pause for a bit. Okay, I had time to think about what we are going to do next. And we are in fact going to factor out the row reduce and row map into a single operation. It's going to be a very interesting exercise. And we're actually going to be using GADTs in order to make that happen. With the feature set in the language that we had previously, it actually wouldn't have been possible to do the kind of abstraction that we need, but now it is. So let me show you how it should be done. Okay, first of all, let's just copy this. We'll start by copying this. And we'll make it, we'll call it just like this. And now, instead of having this, we're going to have a little row operation. Let's make a GADT. Union recursive row operation equals, let's do row map inside GADT. Obviously it needs an output type, and we only need a single input tensor, and that's fine. But in our row map we need output tensor, so let's make it tensor dim int something like that. It's going to take some refining. Let's just okay, let's do this dim what's the problem? Yeah, for all dim t. Okay, so we can consider that as the output tensor for this operation. Now, suppose we had a row reduce. Let's just focus on the output tensors for now. In that case, it would output a tensor like this, and you can see it in the type signature. No, wait, this is the row map. Where is the row reduce is right below it, and yeah, we are passing in this tensor dim b as the output. And here it is tensor dim int b. So far so good. Now suppose we had we could use that to factor out some things, but it's not enough. Suppose we wanted to do both a row map and a row reduce. We are multiple such reductions. We need to have some output in them. So let's do for all dim t tens actually row op. That should be okay. Let's do AB row op dim b row op dim AB. Yeah, so now I hope you're kind of starting to get what we're aiming for here. But is this good enough? Yeah, actually it will be even simpler than I thought it would be. We can just make the two tens or something like row up dim int b, and this is just the and it doesn't need to be like dim int. It should just be dim, because you know, suppose it's a map operation, then you see that we already have the dim int right here, right inside. Of course, the first problem is that, you know, this is no longer a tensor, and it's complaining that unions cannot be applied. And that's pretty sensible. So let's do this. I mean, let rec e function row map to this row up dim t row t and then match x with. Now it shouldn't be complaining about now it shouldn't be complaining about, you know, trying to unify a meta variable outside its scope. And okay, this is fine. We just need to do all the asserts like this: row reduce to from dim to dim. First from dim to dim. Okay. Row pair. Wait, where did you put the underscore? So this is AB. No. It's EA EB. We cannot forget to assert all of these. Assert dim. Assert dim 2. Oh yeah, okay, that's the very first step. And the parts that are factorizing the from array, those are the same in both cases, I think. Like the only real difference is how the to array is handled. So yeah, we have to do something about that. Oh wait, so maybe we need to map over the to array. I mean, okay, we're going to try going in that direction. In what? And let's just call it T for now. To row up dim t, and for all t. And then we actually do need to return a row up, which is what exactly? Tensor I32. Okay, let me just take a look. Or really, it is I32 even here. Okay, but that's after it has been applied here. Or here it's just dim I32. Wait, this is row reduce, and tensor dim b. Oh, so it's a dim. Oh, so there isn't really a need to. So it doesn't really change the dimensions, but over here it does. So okay, that's going to be a bit annoying. How are you going to deal with that? I think okay, this is 2, and it only really does anything over here. Here it just does a single set. Okay, okay, so okay, here's how we're going to do it. Actually, I'm not really sure how we're going to do it. I thought of converting it to a row up, but it's there's a lot of difference. So how exactly are we going to do something like that? Like, we could leave applying I from here. It's fine. And let's okay, let's do the store. Yeah, I need the from and to. Okay, from row. Yeah, but it probably won't be the same row up. Wait. Suppose this thing returns a pair, then there's no way this can be an int. Crap. Okay, as you can see, this requires some thought. I had an idea how to do this previously. I think we're going to have to go to it. Let me just pause here so I can think about it. Okay, I guess I got too far ahead of myself. Here's how we're going to do that. Sorry, I forgot how long I had it paused. What I did was some refactoring, and now it's like this. Once again, I apologize. I simply lost track of things, and I paused it. I forgot to unpause it, but it's not really a too big of a deal. We have this row up, which are just the output arrays, and we also have in the type what local tensor, what local type they are being mapped to. As you can see, in the row map, we have this output tensor, and the local tensor that's mapped to it is this tensor int2. And in fact, whoops. Okay, this should have the same type, I think. Yeah. This should also have the same type. These two, yeah, the pairs shouldn't have the same type. That's fine. Anyway, this is the output array, this is the local array. And in row reduce, you can see that we are not even outputting a tensor, but just a regular value, and that's fine. So in row up, at the very start, you can see how we are asserting the dimensions of the arrays. That's perfect. Now I just need to store the outputs in row up local. So it's complaining that it's unused, and that's basically just this row up local. But I'm kind of confused. Shouldn't I mean, let's just roll with it. Let's just do it, and we'll see where the type errors guide us. Row up dimb local. Okay, so now we are pattern matching on this and destructuring things. And this is okay, first this is the local, this is the to array, local 2. Of course, we're getting a type error because to begin with, we haven't really split this to array properly. What we need to do, yeah, is basically this. I mean, we already have that. Apply index block. And okay, this part is going to require some actual thought. it really was easier to just do everything you know, like this. And yeah, I think we should at least follow the previous structure here somehow. The only thing that I'm not really sure is how we're going to, you know, apply the to array while keeping the structure intact. Okay, maybe maybe I shouldn't be so anal about the way I deal with the outputs. Maybe. Yeah, I think when I don't think about this, I don't really like the way that I'm mapping to the outputs. I mean, there should be a better way of doing that than trying to do this here. I mean, yeah, I'm thinking about to my old work. I mean, I won't call it work, but maybe, you know, studies. When I went through the Software Foundations book, there were a bunch of dependently type techniques in Cook. So I think we had some kind of like, you know, a mapping type, something that takes the to and maps it to local, if that makes sense. I mean, the only real question is how to do it automatically. That's what I'm confused about. Okay, let me pause here so I can think about the next step. I'm kind of stuck here. I mean, this is really my first time trying out a technique like this, and of course I'm going to get lost once or twice. And this kind of, you know, when you get stuck like this, it's kind of an amateur problem. But the thing is, I am an amateur in using GADTs like this, even though I was the one who implemented the language feature itself. But you know, just because you can make a gun or a sword doesn't mean you are good at using it. So I'm going to have to practice a bit first. I'll be back soon. Let me try doing a thing. And that thing will be... This is TensorDim I32B. So let's try making a new case. RowMap dim int RowMap applied. And which type is this supposed to result in? Yeah, it's the same thing. Yeah, so this is fine. Now what we're going to do is map row up dim t to you know, row up the empty. But it's going to be a bit better than how it was before. We also need okay, B local. Yeah, I think also needs to be dim, and that's equal match to with row reduce to row reduce applied row map row map applied. Oh yeah, this is exactly it. You know, I still get the feeling that there's probably a better way of doing this, but I cannot really remember what it would be right now. You know, as I said, I am a bit tired, so we're probably going to have to come back and you know, play with this a bit more so I can figure out the right technique. For now, never mind. And we also need the row pair AB, and that would be EA EB row pair, and this also needs to be recursive. Yeah, great. Also not expected. Wait, why are we getting weird type covers? Did it crash? Oh yeah, it did. It crashed just now for some reason. Okay, so this is a place where we need to stop what we are doing in order to track down this language bug, because the language server must never be crashing, not like this. These kinds of errors are verboten. The language server is crashing, so let me save here. It basically, you know, we can tell based of the semantic highlighting that it started to crash after I put in the error and then the underscore, and then something went very wrong. Let's try restarting it. Why is it not loading? I mean, is it in an infinite loop somewhere? What's going on? Let me close it again. I mean, this is very weird. Okay, let's comment it out completely. I mean, is the process still somehow active in the background? Let's try running this. Oh great, this actually runs correctly. It feels like we have a bunch of errors. The thing is that it's basically the only thing I can conclude is that it's crashing on. It's getting stuck on this. Like, is it in some kind of infinite loop? I don't know. Let's close. Let's open. These kinds of errors are simply the worst. Well, one thing breaks and everything is broken. Wow, this is crazy. Okay, this loads. There's no need to hurry. We'll do it one step at a time. The syntax highlighting for this is broken. And this is so unexpected. I mean, it crashed just once, and that was, you know, something unrelated. That now the syntax highlighting seems to be broken permanently. Like, what the hell? Oh, thank God. Okay. what we're going to do is start going over this. I mean, it's very weird that it's getting stuck even though everything is commented out. I mean, is this some kind of infinite loop in the parser itself? It could be. Like we had a problem that it crashed in the type inferencer, but this error of syntax highlighting not working and there nothing showing up in the terminal might be a separate error altogether. It's sometimes there are errors like this can happen. When you're an expert programmer, you can start to be attuned to these kinds of things. Like an amateur would definitely expect there to be just a single error here, but I'm expecting multiple now. Okay, can I ended up? Let's copy this. Let's paste this. Yeah, this is some kind of parser error. I mean, couldn't the parser somehow be running out of memory? Very bizarre error. Okay. We'll insert the code one by one. And I'm going to have to put this, let's put it here, so I can copy paste it much more easily. It's kind of complicated to have to keep going through the old commits. Infer term subst stack overflow. Okay, we're getting some good information here. Infer loop. Okay, let's see whether we can eyeball it. Let's take a look at the term subst, and we'll see whether it's possible for there to be an error. Let's put this at the very bottom. I mean, we don't have to. We'll get an exhaustiveness error regardless. I mean, could it be that it's trying to run turn subst on a recursive type? Okay, let's do a little check. It's actually pretty easy to figure that out. No, wait. I mean, okay, we have to be careful about the way we are actually doing that. We cannot just test whether the type has been tried once. And okay, to begin with, we also need to understand why it could possibly be crashing here. In for F. It's definitely in add hover. This is fine. Now suppose I try commenting this out. Yeah, now it only works. Let's try. Yeah, now it works all of a sudden. I need to isolate how to actually trigger the error. Yeah, this works as you'd expect. Okay, let's put everything inside again. Yeah, now it crashes. And it's in add hover. even so, suppose we do this. Suppose we comment out everything here. We'll even put some spaces here. Then yeah, then it still actually keeps crashing. That's what I found very weird, and it's not really even giving us a type error here. Okay, I cannot keep doing this on a screencast. Let me pause here, and I'll get back to you once I've isolated the error. Okay, I think I figured why the first error is happening at all. What's happening is that this file is actually pretty large. It's like 654 lines, and when there are too many lines commented out, so something weird is happening under the hood. Like maybe it's running out of memory, I don't know. I mean, it's very weird that we're not getting anything at all. Like, at the very least, the tokenizer should be sending something back. But you know, it doesn't mean that the error is in the error is in the tokenizer. Maybe the block parser is, you know, stuck in an infinite loop somewhere. So okay, I just copy pasted the same thing over and over here. Let's see. Now it's 680 lines. We'll exit, start it again. Not really. And okay, let's try this. I guess it's still too much. 550. Oh yeah, now it's back. So if let's try just copying this a bunch of times. Oh, it works. Okay, what about this? Okay, yeah, now this is crashing. I mean, no, it's not crashing. And an idea occurs to me. I remember that the SignalR library, which I'm using to send messages back and forth to the language server, has a message limit. If there are too many tokens being sent from one end to the other, it might end up throwing them away. And that could explain, you know, let's just close some of these. My very first instinct is that it would, that this kind of thing would end up resulting in an infinite loop or a crash. But you know, I don't think that an infinite loop when parsing comments is very likely. A much more likely problem is somewhere else. So we're going to have to check out. Let's go into the supervisor and what exactly are we using? We're just okay. So here we are setting the minimal logging level. What about the SignalR? Where are we using it to send messages? Enable add SignalR. This is basically a ASP.NET server. We are adding SignalR as a service, as a dependency injection. And get server, I have context, client to server message. Yeah, here we have the spiral hub. I'm just confused where it's actually sending the messages. I have context. This is the SignalR hub, I think. So this is the hub. Hub clients all set core sync. Yeah, so this is the where the message is getting sent. Okay. Okay, client timeout interval. Enable detailed errors. Of course, none of the errors are coming here. Maximum parallel invocation, maximum receive message size. Who knows? Maybe the maybe the problem is the size of the message received by the client. Let's take a look at the VS Code plugin, because I don't see any option for the maximum message size. This is the maximum message size of an incoming message, and this is 32 kilobytes. But then we aren't limiting the outgoing message at all. So maybe the limit is on the other side in the client. We could put in a print on the server to print out to print the sizes of the messages going out. I bet we'll probably find that once it exceeds 32 kilobytes, it starts to run into issues. Okay, here we are making the hub. Okay, I'm not really sure how to configure the size. Okay, maybe no, I'm not sure. Okay, let's ask Bing here. Does the SignalR client have a maximum incoming message size? Yeah, but this is on the server. Oh wait, the maximum client. Okay, let me just take a look at the packages. What was this thing called? Yeah, Microsoft SignalR. This is the client. What about? Oh, long message. Okay, this is very interesting. Okay, assuming it isn't making all of this up, this is going to be very useful. Let's see. Transport. Where's the transport? This is the connection. Okay. So this is after it's built. What the hell? Hub connection builder. I mean, it's either making things up or this is a private setting. Okay, we're going to have to put some log statements. I mean, is this the only build? Log cons and we'll log in the hub connection. Now we'll run this. Let's just first. Okay, it's closed. Spiral server. Wait, not here, but we cannot really log to the console. Instead, what we have to do is you know, I keep getting this fucking error, but you know, it's actually wrong. If we remove it from the package file, it will break everything. So instead of doing this console log, we need a window of show information message. JSON stringify. We'll stringify the hub. Now let's try running it again. Now let's just paste it here. I'll press Alt Z to activate the word wrap. State will connect the buffer size. Win level 4, JSON, features. Basically, I cannot find this transport thing anywhere. So it's probably making it up. Okay, I'm going to pause here and do some research. Be back soon. I've made some progress. What I've done is... no, not here, but in the supervisor. What I've done is simply put a print statement. This is printing the size of all the messages being sent to the client. And you can see the result of that in the terminal. Here are 13, you know, they're pretty small. I thought that they'd be much bigger, but they aren't. So, but if I do something like let's go do something like this. It's not crashing for some reason, but never mind. Now, if we look at the server, we can see that it's not sending any messages at all. So yeah, this is a very weird bug, and it's kind of it's really weird coming programming. You can sometimes step on several mines at once. It's incredible. We haven't even touched the actual error that we wanted to that we should be fixing initially. So I have no idea what to do here. Okay, we'll leave this print statement in for now. It will tell us when something is happening. And I guess at this point we have to put some print statements to see if, you know, if the block parsing is even triggering in the compiler. Let's see. This is going to be the first time I've ever debugged an error like this. Spiral hub, project file open, where at. Supervisor request, file open. And this happens, this is what gets run when a file is open. It goes through a bunch of things. I understood what this was supposed to be, but right now I don't. I mean, I know roughly that, you know, it's trying to memorize as much as possible. Speed text. Oh, this is the text of the entire file. It's trying to find the file in the modules. In the modules. Project revalidate, project validate, project open. I don't think a lot of this code hasn't really been tested very adequately, I think. And the way we are using the URI here is probably the cause of the, you know, the error whenever we open a spiral file in the GitHub history. I mean, whenever we open a Git history for the spiral file, I mean. Okay, so what the hell is this? Okay, what we can do, let's do a put a print fn. File file x file done. And let's just put in a few print statements like this, and we'll start to understand where the break is occurring. So let's take a look at the Spiral server. Oh wait, maybe the incoming, maybe the maximum incoming message size is the problem after all, because it's sending the entire file initially, and let's see, we can go into here and okay, let's open it in File Explorer, and this is 33 kilobytes. And let's just do a brief check. Do we have a larger file anywhere else? Like, for example, yeah, this is 15 kilobytes, as you can see here. What about in the core library? Core base 1414. Oh, they're actually smaller than I thought they would be. Okay, this is small. Tensor M, Tensor main. This is pretty large, but it's still 23 kilobytes. So yeah, so it's very likely that this error is in fact happening because of the maximum incoming message size. If the incoming message size is larger than 32, it will get blocked. Let's get rid of this. And okay, it's in here. X maximum receive message size. Let's make it 1 to the power 20. And this is exactly 1 megabyte. I mean, will it be possible to actually disable it entirely? SignalR. Okay, let's do a little search. SignalR. This is the page that I was looking for. I think I don't think it's possible to, or a good idea to simply disable it. Okay, never mind. We can just leave it on like this. This is 1 megabyte. Now let's publish it. Great, and as you can see, it's not really giving us trouble anymore. Yeah, perfect. Okay, this is definitely going to have to be a fix. That's one issue. Today is 25th. And we're still going to have to fix that type inference error. Let's see. Okay, we can put this back in. Now, what was the problem? Did it crash? Yeah, I did. Yeah, we need to fix this, and now we can actually comment it out properly. Numerically stable. Okay. Where is the raw? Okay, so here is raw. Okay, let's exit and enter it again. Yeah, perfect. Yeah, as you can see, it crashes. It crashed as soon as we uncommented out this function. And what exactly is the problem here? It happened when we did this error type thing. So let's exit and enter it again. And it will probably crash as soon as we comment this in. Yeah. So we know that the issue is in term subst. And you know, okay, well, the error happening there is not really out of the question, because it's following. We have immutable references that point to other nodes, so it's possible for there to be a cycle. It's definitely not out of the question. The only question is how exactly do you want to fix that? So the error can only be in tyvar or ty-metavar, because those two are the only ones that have I mean, is it possible for the error to be in visit? Okay, let me pause here and I'll do some investigation on my own. I'll have to put in some maybe print statements just to see what is happening. It would be best if I could isolate this error somehow, but it may prove to be difficult. I'll be back soon. I did figure out a little thing. When I factor out these two cases like this, it's not crashing. But as soon as we put them all in one case, you'll see that it crashes. Yep. So it's probably unifying these two cases together, and that's causing the issue. But if you look at what the cases actually are, TJ tensor, TJ I32, TK I32, I32. I mean, I'm not sure what exactly it's doing, but there are a bunch of potential cycles. Like, even though they shouldn't be happening, okay, I don't know what the problem is right now. I don't understand why it's crashing, but it probably does have something to do with unification. Infer F, add hover, turn subs T. Okay, we have to make sure that it's impossible for there to be cycles during unification. So some type variable should never unify with another variable during GADT unification if it results in a cycle. Let's close this and we'll go into infer. let's go into GADT. What the hell? GADT unify or unify G. Yeah, it's this function, and this is when unification is done. And if we look at the meta variables, we're actually doing some checking so that it doesn't unify recursive meta variables here. Or here, I mean. Here we are evaluating the unification, but over here we are in type vars, we definitely aren't. And that's an issue. It's an issue that we are going to have to fix. Okay, let me pause here. Yesterday we had to stop in the middle, so let's do some work today. Today what we have to do is figure out, try to resolve that compiler bug. And we're getting an infinite loop in term substitution. So we're going to make it, we're going to make sure that we cannot unify a type variable with another compound structure that contains itself. Of course, unifying a type variable with itself is fine, but not when it's inside some other structure. Like you have a type variable and you don't want to unify it with something like a pair or a record that also has that type variable, because that will create an infinite loop. Basically, this is already done for meta variables here. Recursive meta vars not allowed. And we'll do the same for type variables. mvar those occurs checking for recursive okay. Okay. Now let me just comment this out, and I'm going to think about what I want to do with meta variables later. Recursive meta vars not allowed. Let's type vars not allowed. Got expected. Yeah, we have to keep in mind that we are unifying a type variable with a type variable. And as far as meta variables are concerned, I guess we can just, ignore them. Time meta var. Regarding that error that we are running into, I'm not actually sure why, why it's unifying into a into a NAT or into a recursive loop. I don't know why that is happening, but this place is the only place where that could happen. So it's easy to fix the error, even though I don't understand exactly the sequence of steps the program is taking to get to that point. And that's kind of good. Often when you have something like a memory corruption error, it's very hard to track it down. But you can often know which kinds of operations could make that kind of error possible, and then redesign the system so it cannot possibly happen. Wait, this is var. Oh, wait. Recursive var unification. Yeah, this is fine. Okay, the only thing we have to do is make the type error for it. I mean, the error message for it, I mean. Yeah, I like this. Okay, now let's try building this. Recursive type variables are not allowed. A type variable cannot be unified with a type that has itself. So, row be local. Okay, I don't understand why it's trying to unify with itself here. Be local. Maybe locally is no. This is gonna be it. So maybe B and this tensor have the same type somewhere. Maybe B is either TM or maybe D. Yeah, this is basically the only. This second this B quote has to be inside this tensor TL TM. That's the only explanation. Of course, you can unify a type variable directly with itself, you know. So for that reason, the error cannot be in dim and quote TL or local and quote TM. Anyway, that's one problem resolved. It's not crashing anymore. And okay, so what exactly are we supposed to do here? This is what's this function for? Row map applied, row reduce applied. Okay. And yeah, we are basically applying the indices similarly to how it's done here. For example, oh wait, this is all commented out. Let's put it back in. Like here we are applying the indices outside the loop, and we're also doing that here for both types of operations. Maybe I'll put the row map as the first one. Okay, great. Maybe let's rename it apply outer index. You know, 2 equals apply outer index 2. Wait, sorry, I'm just adjusting my keyboard a little. Okay, not bad. Now it's a bit more solid. Now, okay, let me think. We have the 2. Yeah. Now we also can need the store. Okay, so we don't have to apply the outer index here anymore. So we need to think, why is this giving us trouble here? TU, TV, I32 TT, I32 TV. This is basically the dim thing. TU I32. Okay, I'm a little confused. Let's take a look at this for reference. What exactly is going on here? So 2. This is I32. This is also I32. Okay, so that makes sense. And this dim I32, and it's being applied here. Okay, I see. Okay, so that's what's missing. And if you look at the 2, tensor dim B, Okay, I get it. So dim be local, and over here I think we need to eliminate this. That variable. Okay, so let's do this. Enroll2 equals apply I2 and it's telling us, wait, the problem isn't that this is tu and this is dim. These should be the same type variables, but why does this have I32 and this only I32? That's the confusing part for me. DJ I32 row applied. Oh, well, maybe the problem is just a second. Let's resume. Right now I'm studying this to. Wait, this is. So okay, I get it. It should be like this. As expected, it was an error in the type signature. So let's see. Raw map applied. Oh, really? Oh, wait. One thing that I'm learning right now is that it's actually very, very difficult to deal with all these type variables when using GADT. It's pretty complicated. So yeah, of course, this it's right. It's right like this. The GADT shouldn't change its type. Okay, so oh yeah. So what the fuck am I doing? Okay, that's one. No, it's telling me that TV doesn't equal dim. Okay, that's a problem. So we have this dim here, and it's not the same dim as in the outer scope, but I think we can just remove this for our variable. Yeah, now it checks out. Perfect. Now we can just do the other case. Let's do. This will be row reduce. Row reduce applied. And then let's check out how it was done. Row reduce. Tensor set I result. Wait, what's the result? Oh, there. This is the result. And that's basically it. The only thing I'm curious about is, suppose we did something like raw map local Yeah, this isn't actually an invalid case. I see. But of course, there's nothing really we can do about. Yeah, we haven't actually made the case inexhaustive, and that's with this kind of construction, and that's a bit unfortunate. And I feel, now that we've gone through the exercise, I feel that this is, pretty hard, pretty hacky. It's a bit hard to deal with. An alternative way of doing it. Let's do another version of this. Suppose we wanted both a map and reduce. We could just make this kind of map reduce. And we need two versions of the two tensor, to map and to reduce. And this particular thing would also return a local and a result. I mean, a result of the map operation and the reduce operation. And we do two kinds of stores. But yeah, this would be a third kernel. It won't necessarily be a templated version of this. Okay, so we won't do it. Never mind that for now. I mean, would it be possible to somehow get rid of row map applied and row reduce applied? I'm not sure. I wish it was a bit easier to do a proper construction of this, and instead of having this target here, I wish we could put it in a separate data type that's kind of passed in as a proof holder. But I'm not sure how that could be done automatically. It's kind of it goes against the point of all of this. If you have to make another type that links this to this, if we have to construct it manually, I think in a theory improving system like Coq, you'd have something like a special. You're basically, Coq is very interesting. Coq is a functional language underneath, but you are kind of writing assembly instructions to generate the code for that functional language, which is kind of, it's incredibly ugly and inelegant. I absolutely hate that kind of programming. Languages like Agda and Idris are very elegant, though, in my opinion. But I don't think they're okay. Idris, I think this was back in 2019, so I haven't really been paying attention to what's going on in this space. But Idris does compile to something like Scheme, so you can use it. You could use it to write real programs. Agda, I think not. Agda is more for like pure functional elegance. It has a very elegant syntax with various Unicode characters. It was very illuminating. It's actually it does look very pretty, and I do like when code is like that. It's actually a lot better than what we have in Spiral and F#, but I didn't want to bother, you know, adding various Unicode characters just for the sake of beauty. It would have been a bit too much. Yeah, I kind of hate that we have these two cases. And I hate that they are not directly mapping to RowMap and RowReduce. Okay, let me pause here. I want to think about this more. What we have here is correct, and we could use it to abstract this RowMap and RowReduce, but it's not really enough for me. Oh yeah, we also need to take care of the pair case. Row pair AB, row pair AB, and E A B. We need to make this recursive, and let's name it store. And this should be like B. And what is this? Row pair. Okay, is that fine? Yeah, it should be. Okay, so what I need to do, to do myself is, you know, I take some time to just think about whether there's a better way of doing this, because right now you can have RowMap and RowReduce applied to, and that's not an invalid case. And I'd very much prefer if it was. So, but I'm not sure how that could be done here. Okay, let me pause. Maybe it will turn out to be the case that I cannot think of any way to do this, and then I'll have wasted my time. But you know, when you are new to programming, it's essential to do these kinds of exercises to really understand the full extent of what a feature can do. And you know, while I'm not new to programming itself, I'm new to this feature, so I need to treat myself as a student and just do this. It's actually the fun part of programming. You take a step back and you think how you can design something, how you can use the new tool that you have now. I haven't thought about it yet, but I just realized that we should just release the new version of Spiral. Unifying GADT type variables. Oh yeah, this is perfect. Today is the 26th. And we can exit the extension host, and we'll publish a new thing, PowerShell run. Okay, update this. Yeah, okay, great. Now I can get back to thinking. Hopefully we don't run into any more language bugs. I'll be back soon. Okay. I had time to think about it, and I know a definite way of improving the code that we have written. I haven't. The one thing we cannot really get rid of is this row pair. And arguably even row map applied. A sure way to improve this is to make a nominal type. Let's make a map. Nominal map t. Nominal. And now what we'll do. Reduce and what I'll also do here is add a map. What the hell? Why did these two get selected? Reduce reduce, and that's it. Now if you look at below, if you look at this thing below, okay, this one wasn't supposed to be giving us trouble, and what I wanted to do is make sure that this is a failure. And now this is also for some reason a failure. Wait, did I forget the case? Yeah, I did. Reduce map. Yeah, great. Now, as you can see, these are valid cases, but this one is no longer a valid case. It's here, this one is a reduce, but it's trying to unify with this thing here. I think. Okay, I have no idea why it's giving us such a weird error. Map tensor. This is a map. This is reduce. And this type error is incredibly nonsensical, but at least it's there. So yeah, now the program is a bit more solid. Okay, that's one improvement. I wish we could get away from having this raw map applied and raw reduce applied. I also, try thinking of a separate type that's just meant for pairs, but okay, I'm getting some ideas. Let me go back to bed so I can think about it more. Okay, I figured all of this out. Here's what we're going to do. Union single Oh, not bad. Let's make a yeah, it has a GADTs, so we could also draw it like comp t. Alright, okay, let's do comp a function sin. Oh yeah, alright, oh yeah, this wasn't quite. I didn't think of doing a map like this, but why not? Why not? Okay, I pretty much thought about everything else, and then I started working on this map right now. It wasn't really quite what I expected. So okay. Rec loop. I mean, now I'm confused. What exactly am I doing even? Okay, this is a bust. I guess I need to think about this part more. But as for this part, we can deal with it. First, let's do this. We're going to get rid of the other side. I guess I'll keep around dim. And actually, I don't want to get rid of this too quickly. Let's instead work on this map. Okay, here you have the raw map. Map tensor dim int. I want to get rid of this. I don't want a local type. I want it to only have the output here. I also only wanted to have B. We'll have both of them targeting the same output type over here. Okay, so now the output is tensor int2, and the only thing I'm confused about is why is this tensor dim? Like this is very confusing. Like why is this even correct? Like raw map, local. I guess this type variable doesn't really get used anywhere at all. Okay, so we want this to be tensor dim int. I suppose we can also let's make it like this for now. Ideally, I'd like to get rid of the dim variable from both of these, but we need to link it to the input somehow, so we cannot do that very easily. Alright, actually let me think about this for a bit more. If you look at this one, we have A and B. Like, we could make this tensor dim. I mean, we could make it some input type that's A. Yeah, no, we can't. We definitely need a way of linking the input dimensions with the output dimensions, and that will be impossible unless we have a type variable that's separate from the element types. So okay, let's do it like this. And okay, so we no longer need it. We don't need to be we don't need to be so fancy in this anymore. Tensor dim. Okay, let me just think. Is there a better way of what about this? I mean, it has all the data that it needs. Simply because we now have the map here, and that's what separates out the case from the reduce. You know, previously you had to put in a tensor here and so on, but that's pretty much unnecessary. Okay. I admit I didn't get that far in my thinking previously. I think they should do the trick. This is basically the way to gain programming skill. Instead of just writing down the first thing that comes to mind, take some time to, you know, make it as best as you can. The first time around, it will take you more time, but the second time around, you'll have the experience from doing it right the first time. If you do it wrong the first time, then you will do it wrong the second time as well. Okay, why is this wrong? Oh yeah, it needs the dim. Yeah, that's perfectly fine. I very much like this. AB. Oh yeah, not bad. Not bad at all. So now that we have this, we can split these two away from row up. We can just make this row up applied, row applied up, or yeah, row up applied, because this one is row local. Of course, we're getting a type error. Oh yeah, this is very good. This is amazing. Yeah, it's very clean right now, as you can see. We don't have any more stuff in the type than it needs to be. Okay, yeah, we also need a row of pair applied. I really wish I could get rid of these pairs somehow. Okay, I have an idea how that could be done. You know, let me try it once more. Union rec dim A. Let's make it dim T actually, and then sin from dim. Okay, let's make it fdmt, and that will be fdim_t this needs an explicit kind annotation. Why is it? Oh yeah. I mean, we don't even need to make this a GADT case. It's fully generic. For fdim_a fdim_b so yeah, so I wanted to do something like this basically. We don't need the dim, I think. It can be partially applied in the type itself. Comp fa and now what we'll do, instead of mapping over the type of the element itself, we'll be mapping over the type on the left side. And now, okay, let's take in for all f g t, and this needs to be yeah, not bad. And f t, and it needs to output comp gt. And okay, we also need the mapping function. Let's make it m, and that will be from f to g. Actually, no, that will be ft to gt. Okay, not bad. And now, okay, let's make it this recursive, and then match x with. We don't need to have the x be explicit, so I'll get rid of it and make this function single, and that will be map a f of t. Oh yeah, it needs to AB and oops. Map. Wait, oh crap. No, wait. Okay, let me pause here so I can think about this. It's confusing. Oh yeah, I understand what the problem is here. The problem is that this T is at the top level. We could implement this function if we had higher ranked types. Then we could write something like for all T. But right now the language doesn't have it. Oh my god. Do I have to put this into the language now? Oh god. Oh, this is ridiculous. Oh shit. Okay, let me pause again. This is how it could be implemented, but Spiral simply doesn't have higher rank types. And without them we cannot implement this function. We could implement it using bottom-up features, but who wants to use those? Okay, let me pause here so I can think about what I want to do. Okay, this is so close but so far away. So actually putting higher ranked types into the language with GADTs, they were a straightforward extension, but with this feature we'd have to change fundamentally how the type application works. We'd have to rework how the inference function applies the type variables automatically. I don't really have a good way of doing that right now. Like, maybe I could try dedicating two weeks to this and trying to get it to work, but I don't really want to do that. We managed to get the GADTs into the language in a record time, but as for this, yeah, this will be quite hard. So I guess we'll go with the regular approach. We'll just have the pair cases inside the node trees themselves. And that will resolve the problem. Row up local. This is B. Row up dim B. And as for this, row up dim row up applied. Wait, it's here. Row up. This is, yeah, not a local, but just B. Row up applied. We also need to pass the dim. Oh, okay, perfect. Row pair applied. Yeah, great. Now these three cases are the only ones that are going to be valid. Suppose we did something, oops, like this, and then row map applied. We get a type error here immediately. It has a map and a type variable, and here is a regular type variable. So that's the problem. Reduced. Yeah, it's not good. And then now this is pretty much ironed out. Everything is the way it should be. And I don't think it's that hard to understand. And now we can get rid of this, and we could implement it in terms of just the row operation. So let's do it. And fun config xij tensor, and we need to return a tensor here. So match row map. I mean, no, not this, but yeah, we need to do this. Row map, and then config xij tensor. And from is going to go in as it is, and this one needs to be simply row map and 2. Pretty simple. kind of want. I mean, it can remain like this, whatever. Or actually, no. Let me rename it. Let's do this. 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 Okay. Let's get rid of this. And then row config exij_tensor. This will be row reduce. Now we can implement another function very easily. In row map reduce. Okay, let's copy it. Let's copy this. And okay, it will be a bit different because let's do this. It also needs that C. Okay, let's make this C, and this one will be B. From to okay. This needs to be row pair, and then this will be row map. Let's do it like this, and then okay, what? Okay, I see. So in AB. Oh yeah, perfect. Row pair reduce row map. It's great that we got a type error. Indeed, the target type should be C instead of B for the reduction. The type inference really worked well here. Not bad. And we can be pretty sure that this is correct, simply because the types themselves are correct. And it's not really much worse than, having these pair types is not that much worse than the next best alternative, which would be to make that composite type and then use that to abstract the iteration over these. It's perfectly fine. Maybe let me just put this on its own row. Oh yeah, this is wonderful. Well, let's just stop for a minute to admire this. Like at the very start, we had like two type variables here, and we were putting in tensors, and it wasn't even eliminating the other cases from being possible. Like you could have row map and then row reduce local. Let's make this local. What the hell? And arguably, if we had, this one, we could derive the other two from it, but it won't be as efficient, because we'd have to, if we are just using the map, then the reduce output tensor would be useless, but it will still need to be allocated. And this has exactly the optimal amount of code sharing. And yeah, it's very wonderful how we have this, and then it allows us to share the types. I mean, are we even using them anywhere at all? No. Oh yeah, perfect. And having the map and the reduce type here is stroke genius. The only thing that I don't like is that they are the unit types. It would have been better if there were void types, so they are completely unconstructible. But they can still be like this. Yeah, it's perfectly fine. Like, they don't actually get used anywhere in the body itself. And because we have the map and the reduce nominals in here, they very succinctly separate out the map and the reduce cases. We don't have to put in tensor with a specific dimension here. We just have the map and the reduce. And it becomes very easy because of that to map from row up to row up applied. Wait, we still have the dim here. What the hell? Wait, then Yeah, perfect. You look at this for a few moments, and in the meantime, I'm going to have a break so I can eat some watermelon. I've been taking breaks way too often, but that's going to continue until the summer's over. I need to get my exercise and so on. I think I keep going to bed too late, so the 2 hours that I miss in the morning is really hurting me. But I'm enjoying my life, a program for a few hours after noon, and then go swimming, and then play computer games, and that's my life currently, and it's not bad at all. I'm not really looking for money, I'm just afraid about the long term. Oh wait, this is wrong now. Oh yeah, we can get rid of the thing here. Perfect. So we're going to stop here, and after it's time to resume, we're going to take a look at whether all of this still works with the new operations. Wait, why is this wrong? Wait, this is map, and did we do something to... Oh yes, we have the map and reduce nominals right now. Okay, so what do we do about this? We have to change them to something else. Like, I really wish these were just local types instead of... Okay, let's... what we'll do is simply put this at the very top. Used in row. Okay, not bad. And I don't see any errors. No, nothing here. So let's make a commit. We'll test these after the break. I'll see you in a few moments. Let's resume. It's time to finally test this. During the break, I've been looking at Girls Frontline 2 cutscenes, and they're pretty interesting. I'm kind of getting hyped for the game. It will have a global release in the future. I really hope that the gameplay isn't really bad. Okay, let's see. This. Okay, let's build this. The changes that we've made to RowReduce and RowMap are very unlikely to actually break anything. Okay, so first of all, let's go from... Okay, this is the Softmax scan. As you can see, it ends at 0. I kind of it's hard to... Okay, okay, it starts at very close to 1. I mean, very close to 0. And okay, this is... I guess this is the discrete sample. Oh no, this is the argmax actually. Sorry about this. Let me just scroll down a little. Okay, this is the softmax. Now where was the argmax? Here it is. And then comes the layer normalization. And this is the masked softmax. 13, 39, that's roughly 50. 18, 28, yeah, that's also roughly 50. 7, 6, 56, 30. Oh yeah, that sums up to 1. I'm pretty sure that this works. And output reduce, let's see, what is it reducing exactly? Output reduce. This is the output reduce, and it's summing up the input. And the input normal, mean, standard deviation of 1. But you know, it doesn't mean that it will be around 0. If we, let's try it a few more. In fact, let's turn the, let's comment. Oh, for fuck's sake! Oh, what did I do? Let's comment out this. We'll bid it again, and then we'll try running it a few times to see what comes out. 4061. 3085. Oh yeah, so I understand why this is happening. Here we are adding 1 to input, and we're doing that in a mutable fashion. So the average of all the elements is now 1, and we have 2 to the power of 12 elements. That's 4096 elements, and now we're seeing 4021 here, 39, 40, 61. If we run it a few more times, we should get a number that's above 4096. Wait, how much is actually the okay, 2 to the power 12. Python 2 yeah, 4096. And that was right after all, it seems. What the hell? I keep pressing stupid keys by accident. Exit. Control Z plus return. Okay, let's try running it like this. Yeah, for some reason they're consistently below 4096. We're getting a few that are above, but you know, maybe maybe we're simply getting fooled by randomness here. $4,176. Okay, let's stop wasting time with this. It works. So let's get back to what we were doing before, which was something with the masked softmax. Oh yeah, the reason why we did this is because yeah, we wanted like multiple outputs in a. We wanted a masked softmax, and we also wanted we also wanted to do discrete sampling in a single kernel. So why don't we implement that? We have the local softmax. Okay, here's the masked average. Local discrete sampling. Okay, so okay, so what we could do here. First of all, let's change this one. You know, x equals this, and then on the left side we also have to return the probabilities, and that will return a tensor and this I32, which is the result of the reduction. And we have the RowMapReduce primitive now. We've implemented it like right here using this. And doing it like this is better than copy pasting everywhere. Maybe doing it with copy pasting initially was better, but after that you can see the commonalities in their functionality. And also keep in mind, we implemented this function originally before we had GADTs, so we had no good way of actually factoring, of doing the abstractions in the top-down segment. We could have done it in the bottom-up segment, but nobody wants to program in that. Unless they have to. The top-down segment is the best, but the bottom-up segment is necessary. So we have this RowMapReduce, and when it comes to doing the softmax and discrete sampling layers, we're going to be using the new RowMapReduce primitive. Also, let's implement. We need this local masked softmax and discrete sampling. And masked. And we also need, when it comes to the masked softmax, I think we need to, we need to pass in the masking function. Not bad. And this should be, we also need to put in I and J tensor. Oh yeah, not bad. And you can see here quite clearly how easy Spiral makes it to fuse CUDA functions together. This will all be fused into the same kernel now. I cannot imagine how hard this would be in C++. I mean, a lot of the stuff that Spiral can do, C++ simply can't. C++ is especially bad at functions, ironically. So instead of having a proper function type, you instead have to pass in, naked objects, which are callables. I didn't really understand. If you do an auto, and then you kind of and then you do a lambda. I didn't really understand the, actually I didn't even bother understanding it, but I only really understood what it's doing under the hood after I've implemented bottom-up functions in Spiral. They don't really have a concrete type. They have something like an ionic identity, but not necessarily a type. And the way the C++ does type inference is very similar to how Spiral in bottom-up also does type inference. I think Rust has the same issues regarding its closures. It doesn't have the capability to neatly just put them on the heap. So don't quote me on that. I'm not really familiar with Rust. I mean, that's basically what I've heard while reading stuff online. I mean, I heard that Rust isn't good on... isn't good for functional programming. What do you think? If you disagree, post in the comments. Maybe educate me a little. Mass softmax. Okay, so we have this. And this one fuse the mass, the softmax, and the discrete sampling function. And this will allow us to get the path probabilities. Now we're done with this here. Oh yeah, we also commented about all of this because, the error that we ran into with message sizes was really confusing. First we ran into the type inference crash because it was unifying a recursive loop. And then as soon as we stepped on that mine, another one exploded. Which is the message size, and I was right. There were two errors, two different errors, and they are actually completely unrelated to each other. It's funny how that happens. Okay, so what do we do here? We have the layers, we have the graph. Oh yeah, why don't we add BlockRowMapReduce? That's what we need to do now. A, B. Wait. This is the output tensor. I mean the output node. This is T. Oh, this is A. Oh, wait. What's A? Wait, A is no. A is the input and T is the output. Okay, let's go from top to bottom because I'm going from bottom to top and I'm just getting confused here. This is A and this is B. And this is what exactly? I think, yeah, this is the input tensor. Oh, that's fine. This is the output tensor. I guess we need two of them now. This is int dim and the other one is int dim int. Okay, so okay, let's do, I guess they'll have to come in a pair. Okay, tensor int dim int A. Perfect. And we don't need, we could have a row of map reduce that, takes in multiple, that produces multiple map outputs in separate tensors, but the reason why we don't need that is simply because, actually, instead of having BlockRowMapReduce, we could reuse the types that we actually have in the row function itself. Like, we could replace this tree with a single row function and make the graph a lot easier to deal with. Do I want to go with that? I'm not sure. Let's go with this for now. I don't feel like redesigning literally everything. I don't know how I would need to handle the row of operations over here. It will be a pain in the ass. I probably need to add nodes just for the row operations, and I don't want to do that. So okay, BlockRowMapReduce. BlockRowMapReduce a out looks what do you think about this? This is graph 10. So why is this giving us an error? BlockRowMapReduce. We're propagating the dimension of a single node, and here we need to output multiple dimensions. That isn't good. I guess we cannot even add this node over here. Oh, what a problem. This is weird. What about the pair nodes? I guess, okay, then deploy, but what about the pair nodes in GADT? Zip pair. So this wouldn't even be called on a pair node ever, and it takes in the get. It takes in the hash map explicitly. Okay. Okay, it didn't occur to me to really think what we wanted to do here. Okay, let's leave this out for now. I'm not sure whether this is not being able to support this is a fatal error. I'm simply not sure right now. And pair. Okay, where is the GADT used? Wait. Okay, so I think we're only using GADT over here. we are using that in the out, or in the pair we're just passing through. And yeah, in the output we have this GADT, and if we call that on BlockRowMapReduce, yeah, we definitely need the dim from BlockRowMapReduce, and that's a huge problem. Okay, let me pause here. I need to think about this. Okay, I had time to think about this, and I know what we are going to do. We're going to use a type that's very similar to the compound type that we made before. Excuse me. One of the legs on my keyboard weirdly came unscrewed. I have no idea why that happened. So, as I was saying, what we're going to do is use a compound type to get to propagate the dimensions. Nominal. Okay, let's make it. I mean, we're using dim everywhere, so instead of using dim, I wish we could use something better. Whatever. Well, let's make it a tensor dim. And we'll have a D case. We'll have one type for all dim T. And then tensor dim, but not the tensor, not here. Here we just have the type for the tensor, and over here, excuse me for a moment. I finally configured the keyboard properly. Over here we'll have the tensor dim, and it will have a type of tensor dim T. And why is this a parsing error? We need a union, a recursive union. And over here we'll have a pair. It stands for a pair for all AB, and it will have actually dim A, dim B, and AB, and it will have dim A here, dim B here, and then tensor dim AA, tensor dim BB. And yeah, this is instead of returning a dim top, we're going to be returning this tensor type from here on out. And instead of passing in the tensor, we're going to pass in all the types. But we're going to make sure that you know, if it's a scalar, it's going to be a type error at partial evaluation time, so it's not going to change much compared to how it worked. And that will allow us to have this BlockRowMapReduce. We are also going to have the pair to do, and this one is also to do. We'll move them up once we're done. So do we need anything else? Zipper, weight, apply, key tensor, key scalar. Yeah, pretty much nothing. We're fine here. And we're going to have this function, this part here, we're going to factor it out and have it operate on that tensor dim type. So it's going to output multiple partitions. But at the end it doesn't really matter, since it's just outputting the unit type. It's not really returning anything in particular. It's going to be an easy refactor. And we're finally going to stop here for the day, because I need to go to the beach to get some exercise. And yeah, maybe we'll have longer hours once I get tired of gaming. I'm enjoying myself right now, so I might as well continue living as I have. See you in probably tomorrow.